Okay. Say for instance, in New York, you are there, and New York, you know how busy the streets are, how busy the city is, and if you don't have any proper system like the advancement of identification, identifying the face recognition, because it's already very uh, the criminal records, the crime rate is too high in the city, and even though they have very advanced the um, the CCTVs basically, yes. But still it is not like China. In China, if you go to maybe their capital city, right? If you just two times or three times, if you're just walking around the signal or somewhere, not only the signal, if you're just going in and around unwantedly, then immediately you will be picked up by police department. Why you are just because that much facial identification, even the very accurate details they can retrieve, just applying this technique. This is really, it's happening, and it's not a just a WhatsApp message. It is happening. Okay. And that is how they are just controlling the crimes. Okay. And um, and it's one of the model is like YOLO. It is a really advanced facial detection, and it is working like anything. It has been proved, and it has been implemented in so many object oriented devices like CCTVs. I mean, advanced CCTVs, advanced signal
Actually,
processing system. Yeah. Yes.
Actually, departments use these
Yes,
form
obviously.
detection.
Yes.
Recently,
So,
it was in Hyderabad
hmm.
as well.
Oh, okay. So the behind the scene, CNN is there. Okay, that is what I'm trying to say. So behind the scenes, CNN is the basic foundational algorithm, and then they build a lot of other things as well. So how this, getting images. Just a second, I will drink some water. And the CNN image classification takes an input image, process it, and classify it under certain categories, right? Now, how it is getting identified, whether it is a living organism or non-living things like dog, cat, whatever the image, right? The computer sees an input image as array of pixels. Okay, that is why whatever the image you are doing, it is based on the pixel. It is not just the weightage of the size or weight or something else. It is arranged in a manner. It is called as pixel, and it is an array of pixels. So this is called as an array of pixels. Okay. Right? This is an array of pixels. Okay. And it depends on the image resolution. So based on the image resolution, it will see height, width, and dimension. Okay, height, width, and dimension. So an image of 6 by 6 by 3, it means that height 6, weight 6, and 3D, three dimension array of matrix of RGB. So 3 refers to the RGB values. So this dimension is nothing but the color combinations of the image. Okay. So basically, it is this is the color combinations. RGB is the, I think you might know how computer is just taking the color. So an image of 4 by 4 by 1 array of matrix of one is only single color, that is a grayscale image. So it is a kind of a black and white. Okay. Okay. So technically, deep learning CNN models to train and test each input image will pass it through a series of convolution layers. I think in the last, what are layers, right? This is called as layer. We'll see, in depth with filters. Okay, pooling. These are all the terminology in CNN. Pooling, filters, kernels, fully connected layers. That is called FC. Okay, and apply softmax function. Softmax is nothing but we just saw about the ReLU function in ANN, right? It is one of the uh, function, a kind of a ReLU function, the softmax. Softmax, this is only used in the image recognition uh, only for CNN. Okay, so we'll see how the softmax has been applied, this function, and then how it has been identifying or classifying an image or an object. So we have to apply softmax function to classify an object with probabilistic values between 0 and 1. So the below figure is a complete flow of CNN to process an input image and classifies the object based on values. Okay, so what is this image? So this is the car image. You are just giving the input to this convoluted layer, right? The first convolution is happening. That is, it is trying to identify what this image is all about by layer through ReLU function along with the ReLU. So ReLU is nothing but yeah. Okay, let's try the activation function. Okay, did I show this? This bookmark? Did I show this? The playground of TensorFlow, right? Okay. So here there are so many informations, we need to discuss, right? Okay. Before that, I will introduce that, and then we'll come. Now the word has come that is called as activation function. Without activation function, you can't run any kind of a deep neural network. Deep neural network in the sense ANN, CNN, what all the things are. I mean RNN, all the neural networks are a deep neural network. And how it is getting identified? There is one function called activation function. So the activation functions are mathematical functions used in deep learning to introduce non-linearity into the neural network, enabling it to learn and model complex patterns in the data. Okay, because it is not a linear functionality we are asking in the algorithm or a system, right, or a model. It is all about the non-linearity. You can give any image, the model has to identify. That is what our problem statement. So if that is the case, and it has to apply some mathematical functionalities towards the neural network, then only it will be able to understand or identify something. Because we are going to imitate the brain functionality into this, the artificial system of neural network, right? So ANN is different, and whatever I'm saying, that is different. So artificial, the neural network, it is like how it is getting identified or how we are applying this technique to identify like a human being, right? So they're having some mathematical functionalities so that they'll be enabling are implementing to identify any particular image. Okay. So enabling it to learn and model complex patterns in the data. Without activation functions, a neural network would essentially behave like a linear regression model, regardless of its steps. If it is acting like a linear regression model, then we have already basic machine learning. Why we are going for a deep learning model, right? That is why we are applying the non-linearity in these functions. If you are going for non-linearity in deep learning, then you should have a these activation functions. If you are not using activation functions, it will be they're saying it will be acting like a linear regression models, and it never identify the depth of the image. It will be giving a vague result. It won't give you the optimum result. Okay. What is non-linearity? So they allow the network to learn non-linear relationships in the data and decision boundaries. By introducing non-linearity, the network can define complex decision boundaries. And gradient flow, they play a role in controlling how gradients flow during back propagation. So I think during the ANN, I said I used this back propagation, like, they're just going are doing the reverse engineering in the feed forward network. See how our mind or how our brain works. If you happen to see any kind of a data or any kind of a people, immediately our mind, trying to identify some relationship. What is the relationship between me and the person who is just opposite, standing, I'm just seeing, looking around the person. Even if you are just watching a movie, your mind will always calculate something. I have seen this guy in some other movies. What is kind of a relation and relating to somewhere, right? And some point, we'll be able to remember based on our age and based on our memory power, based on so much of information we have in our mind, how we are relating, right? And also the similar case, like right, if you think deeply uh, or repeatedly, then you will get remember, right? The neurons, how much neurons you have in your brain, almost 86 billion neuron billion. Okay, 1 billion is 100 crore. 86 billion neurons are there in our brain. So all the things, whatever we acquired, the knowledge, uh, we are not, you know, we are not thinking like a storage device, right? That is how, um, our the nature of brain structure is. Otherwise, everybody will be like acting as a mental, will be in a mental state. Mental state is like high or low or whatever it is. Some people in the streets, you would have seen, like, they'll be talking unrelatedly. Uh, in one sentence, they'll be just, kind of shouting. The another sentence, they'll be acting like, they are just very, very emotional statements. And the other thing is irrelevant to this kind of thing. That means their mind is not in steady state. They are thinking too much, and the brain is not in steady state. That is why, they are in that mental state. But the normal human being, we are very, very steady. That means we have a good sleep, right? The sound sleep, good sleep in the sense, sound sleep, and you are giving rest to your brain, and that is why it is being in balanced state. If you are feeling imbalance, then only we'll be in, maybe, it will be happening like during your meeting. Somebody was saying, maybe your boss or somebody, give unwanted statement to you during the appraisal process, right? That will keep on going in your mind, like, month or 2 months. If you have that, keeping in your mind, you will be in, imbalanced behavior, and you will be getting anger, you will be getting stressed, you'll be pressurized, and you feel that how much we have done for this company to grow, and she is saying like this. And these are all the things nowadays, which is very very common in every organizations, right? Whoever knows to balance this kind of a structure, they don't have getting under pressurized or stressed out or something else. So we have to be balanced. So that is why I would say your life is in AI and AI is in, because we know how to balance. If you study in depth the neural network, I'm sure that you'll control any kind of a situation, any kind of a boss, any kind of a team members, any kind of a team player, any kind of a people, I would say. If you're meeting the stranger, you'll be able to control even the stranger itself. Okay. um, uh, I mean, because I'm seeing for the past 7 years, I'm implementing not implementing, I'm just observing what I have studied and what the neural network is just becoming, and what all the objects. There are so many objects. There are so many instruments we are using in our life, and how it is relatable to them, and how we are controlling, and that is how I improved. I'm in the improved state of handling the people, handling any crowd in that matter, and that is how I getting inputs, these kind of CNNs, how I'm just from in front of me, any crowd or any person who's just standing or sitting, I'll be able to uh, discuss with them without any judgment. I mean, there's so many other things and psychological thing. That is why I used to say psychology also is there in AI. Otherwise, we will not be able to build an application. Okay, so AI is literally, we are just dealing with the emotions, sometimes blindfolded emotions, without emotions, with emotions. That is why we are having sentiment analysis separately. There are so many other factors that are involved. Okay, especially if you are dealing with the CNN. From this CNN onwards, you have to get into the approach of, you are dealing with the psychological informations. So as of now, we are just dealing with image. If you are just starting to deal with videos, audios, uh, the the other things, then you will be able to know where this function is implied, especially while you are ordering Amazon product. These kind of things are there. So nowadays, they are improvising their image recognition information, like the jewelry shop. If you are having jewelry shop, even from wherever you are, you'll be able to order. So if you're just ordering a ring for your hand, right, your finger, you automatically captures your finger size. And actually it is very very tough and challenging job. And nowadays it is getting uh, uh, I think even tailor. Okay, so if you are ordering um, I mean, your jacket or something, right? So your body, I mean, it has been measured, your body, like you should, I mean, all the things, and you should have a very high or HD camera, web camera, or whatever it is. That's it. And Amazon is, I think is they are going to implement, and some of the applications they already implemented it, but it costs you more. But some companies are don't have to worry about this infrastructure cost, because they are getting retaining the new customers, and also the existing customers. Whoever is not coming to the shop, and they are just making them happy. Okay. So that is also in plan. In a lot of applications, this application also will come into place. Okay. So you'll be able to see this kind of innovation very soon. Okay, so there the activation function is very important. That is, one of the activation function is sigmoid. It has its own formula, it has its range, and how it is useful for a probabilities, and how it is useful for identifying this smooth gradient. So probabilities in the sense, what is actually in this image. By using sigmoid, and it is trying to find out what is inside the image, what is the color, and what is this image all about, and it is trying to identify based on the probabilistic nature, and, and that is most important, right? I mean, system won't understand what it is because we have to give the chance, and chance is nothing but the training. So how many images you are just uh, trying to implement, that much information will be getting trained. So can you just open right now the CNN folder in your laptop, and I will show you how many images are getting trained, and just to closely watch that images, different kinds of images. It is not a single image like a passport image, passport size image. No, it is a different angle they would have taken. Just open up, and then we'll move on to this. Maybe I will give you. I will stop share. I will come back to this. The first now. Yeah. Just open up your Sandil, just open up your CNN folder.
1 minute. And I mean, we have to upload that this one, right?
The folder
Convolutional
convolutional neural network folder is there in your
Okay, yeah.
A to
Let
Z.
me
Yeah.
under the deep learning. Okay.
Mm-hmm.
Should we open this Python program?
Yes, yes. Open that. Open anything. Maybe.
Okay.
But I want to.
And there is no CSV file now, Sini.
It should be there, isn't it?
Yeah, convolutional we don't have.
File, yes.
There's no data.
There are no data.
Okay. Okay. I will send you right away. Just a moment. Send message. Mhm. Recently, I've sent this file.
Is it the same churn modeling CSV we should
No,
use?
no. That's an image, pure image. That will send you. I think I've sent from. I'm just searching for the watch.
But in the code, they are not using any file kind of. Only they import directly. They import generated data generated image data generated. That's it.
Okay. I
So
think
we don't require. One minute. Let me share the
online
screen.
itself. Okay, let me.
Yeah.
Okay.
Let me.
Okay, I will give you. Okay, so open it, and I will show you the data itself, online itself. Ah,
So here.
image import image data. Okay. No. Open new tab, and I will show you the data where it is. Open new tab. Super data science. Right? Super data science. Super data science. CNN data. Super data science. CNN data. Super data science space CNN data. Yes, data set. Yes, open that. And now you'll be able to download around the 4,000 images of a dog image and a cat image. And the thing is, you have to call this zip as zip file itself in the code. Okay, so then only it will be able to read. Otherwise, we want data. Just a search. I'll also recently I've sent them. Solomon.
We need an image.
Yes, yes, you need an image. We need to
There
train
are
those images. Couldn't find the data set.
no.
Yeah.
It's a bunch of. Okay, just search for it and I will give you the information. No worries.
Here, I think third link, deep learning and neural network datasets download. No.
We need a CNN later. That mean image related data set.
I found it just. Recently, I've sent attached to the other group, the WhatsApp. Let's see. In the beginning itself, in the beginning of the page itself, you'll be finding the data set. Welcome to the course. Okay. Okay, I'll share this. In our WhatsApp, and I will share the link. And just click that link, and I'll show you how to download this. I've shared the link.
Can you share it here, chat box, this one, chat box?
Yes. Let's see.
This one.
Yes, here, data sets. Go to the data sets. Yeah, go to the data set. Yeah, part 0, there is a data sets. Just,
That's what I downloading this
yes,
one.
Yes. Okay.
Yeah.
Okay. I think that is it has its own. That is where.
Oh, 2 hours left.
What happened?
It's 1 hour left. That
No,
much
only
big data.
263 MB, right? And
2.5 MB of
let me.
2 hours left.
Yeah, I have downloaded it. Don't worry. It's my I will just send it through WhatsApp itself. Just stop it.
It is showing me 5 minutes.
Yeah, check your WhatsApp.
2 minutes.
Even you have to download the WhatsApp. And it has its all images. So going forward, you have to know how to read the data sets online itself. And even there is a simple methodology in Google Colab. You can just you can read the zip file as it is, and you can whatever you want you can access from that. So you have to search for how to read the zip file.
Mhm.
Yeah. Yes.
So directly put a zip file. We don't need to
Yes. Yes. No need to
extract
extract.
and
Yes. Yes. Exactly.
Mhm.
Yes. There is a training set. There are so much information. Yes. It's a very huge file.
Until your screen got stuck actually.
Oh, this can you see? I'm moving.
No, your screen is not loading fully.
Okay, no worries. Let it be, and I will share my screen. Okay. So
Okay.
stop it. And I have sent enough information to you, and you just go and later point it down. How do I reclaim this? Reclaim. And, what I wanted to show you. Yeah, this is ANN data set. Here it is there, and the CNN data set is there. Okay, and I have shared you through WhatsApp. So once you are ready, you can. This is the data set. Okay, this is the training data set. This is a test data set, and this is a single prediction data set. So here, what is the ultimate goal? To find out if you are giving any single prediction, whether it is a cat or dog, it has to identify whether it is a okay, so that is the object. It's a face detection, an object detection. So if you see this training data set, there are cat position. There are so much of yes. I will open the this. Yes. Let's see. I'll maximize this. Okay. So this is the cat training data set. Let's see the okay. This is one. This is different kinds of a position. Okay. Let's see. So and if you give too much of information to train this model, then only it will be able to train the model. Then only it will be able to identify. It is not a same image you shouldn't give. It is a different set of images. See how many, I think 4,000 images are there. That is why it's a huge. Okay, I think 4,000, yes. See, 4,000 images. Because for deep learning, you need more and more and more information for the model to be trained on. Otherwise, your accuracy won't be good enough. So the different kinds of attack, different kinds of the positions, posture. Then only it will be able to read all the array of information. Array of information in the sense, if you take this image, it will just read the entire thing like an array. Okay, that's a square box right there, and then it will just uh, trying to identify. But the once you give the activation function, what it will read, I'm just simply simple layman terms. It won't read all the other unwanted information. While you are activating the function, it won't read this kind of information. It will store in their memory only the dog face, nose, eyes, and ears, and whatever the spur, the information it needs to identify. It will store only that piece of information. That is the power of CNN. And it won't store all the windows and all the wall, the image. No, it won't store. And even this is, I think, even somebody's hands or something. It won't read all these things. Okay, this is how CNN simply reads through if you just give the activation function. If you just give the activation function, I will just read. Okay, I will show you one important information over here.
You open this playground now.
This is the playground. Yeah, I will give you this.
I finished downloading the data sets actually.
Oh, okay, good. Okay. You can just go to the code in chat, and I will share this in this playground of TensorFlow. Okay. Here, this is number of. If I start this, okay, I think in ANN I should just simply shown, but I'm not sure whether your team or some other thing. This I will show this again. Okay, I'm just starting this epoch. I mean iteration. Okay, it is going on. The epoch is going on and on and on with the features that the data is there here, and I will change the data set. I will just so here 4 different types of data sets. Okay, this is also nice. Okay, this is the data. This is the input, and this is the epoch. It is just show going like anything. See, so 200, 300, 250 iterations. The epoch is just running behind the scene, and it is just flowing the data. It is applying this only this thing. Or if I want to introduce these features, or if I want to select how many neurons I want, only one neuron, two neuron, three neurons, how many. This is the input from one neuron. Hover it to see larger. And if I wanted to, these are all the hidden layers. In ANN, we have seen the hidden layers as well. Okay. If I wanted to, give more neurons, like this is one hidden neurons, hidden layer or neuron. Okay, try to understand. This is how the layer has been specified. This is one layer, and this is two layers. Okay, if I wanted to add more layers, it depends on your model. That is why they are just showing like how many, and you can just add whatever the hidden layer, how many hidden layers you want. That's up to you, so that your model has to be perfect. Here we have to know what is meant by learning rate, and this is the activation function. Tan H is one of the activation functions. Here, ReLU is one of the activation function, which is very, very famous in deep learning. Sigmoid, Tan H, and linear. These are all, these three models, I mean, activation functions is very, very less in usage, but ReLU is the most common usage. Okay. And if you use the ReLU function, it will be acting like anything. Your model would be, automatically getting perfect, and it is doing a lot of other things as well. You'll be seeing what is ReLU needs. And then regularization with one layer or two layer. You decide. Okay. And the regularization rate. So it starts from, basically it starts from 0 to 1, up to more than 3 and 10. It is a over precised model. We don't have that much infrastructure right now. And the classification type, is it a classification or a regression type? Mostly if you are using a neural network, it would be a classification. That is why we are going for it. Okay. So I have sent this link. You can just try learning and how this learning rate, when this learning rate is getting optimized. Let's see the. Yes, I've selected too much of 3 hidden layers, 6 neurons over here. It is doing very
Data
fast.
set we need to provide as any data set
Here,
we need to provide.
here, data set is already there. The type of data set,
Okay.
you don't need to provide anything. See, the epoch is trying to find out the ReLU activation function for L2 regularization and towards 0. Okay, the classification model. I'm just see now the epoch is slowly going to stop it, and it is trying to find out its optimal epoch. This is the playground, and this is a kind of for user to understand how neural network is working. And this is from TensorFlow. Okay.